So this is not even, we're going to be starting tomorrow with chapter 6, right? And this is not even, this is back semester 1 stuff when we graphed y equals mx plus b. But if you don't know how to graph lines, there is no way you're going to be able to succeed in chapter 6, all right? So let's just do a couple of these. Maybe I'll do all of them, but in this class I'll just do a couple. We're going to graph using slope-intercept form. And number one, if we remember correctly what slope-intercept form is, it's y equals mx plus b, okay? Where the m is the slope, the number in front of the x, and where the b value is the number that's being added or subtracted at the very end, okay? And just in case you forgot, over the past 2 weeks, the b value, it tells you where your y-intercept is at. So we know that it's going to cross the y-axis at 4. So this is the y-axis. This is the x-axis. So it's going to cross the y-axis at 4. So here's 0. Here's 1, 2, 3, 4. Everybody put a dot right there, please, at 4. And now from that dot, we need to know the slope. And the slope is the number in front of x. And what number is right here in front of x? 1, right? If there's no number, you know it's a 1. So they even put these spots right here that the slope is 1 and you want it as a fraction, so we put it 1 over 1, and the b value is 4. So we already know it crosses at 4, and from this point I'm going to go 1 over 1. Again, you want it as a fraction because, just in case you forgot, the slope is rise over run. You want it to be a fraction. The rise could be positive if it's going up, or it could be negative if it's going down. Or better said, if you do see a positive fraction, it will be going up. Or if you see a negative fraction, it's going to be going down. But the run, you always look at lines from left to right. So you're always going to be running in a positive direction. Okay. So when we look at this point and we know it goes up 1 over 1, we're going to go up 1 because it's positive. If it were negative, we'd be going down 1. But we're going up 1 because the slope is positive. We're going to go over 1, and we're going to put a dot right there. And of course, you could keep going up 1 over 1, up 1 over 1 to get as many coordinates as you need. Or you could even use the pattern backwards. Instead of going up 1 over 1, you could go over 1 and then down 1, over 1 and then down 1, and put a dot right there. So the slope pattern lets you extend the line perfectly straight without using a ruler. And then, of course, you just connect the dots, and that's it. Now, just a review. What does this line represent? Anybody remember what this line represents? That is slope-intercept form, that's correct. But when we actually graph a line, this line right here is made of billions and billions of points, right? Right here we have 1, 2, 3, 4, 5, but there's technically, it goes on forever. So there's millions and millions of points. There's an infinite amount of points. But what do those points actually represent? Anybody remember that from semester 1? It represents the answers, the solutions to this equation, okay? So for example, if I pick any of these coordinates, let's say I pick the coordinate 1 on the x, 1, 2, 3, 4, 5 on the y. 1, 5, all right? Let me actually write that right here. This coordinate right here is 1, 5. That is a solution to this equation. If I plug in a 1 for x right there and a 5 for y right there, because the coordinate's 1, 5, that would say 5 equals 1 plus 4, and that's a true statement. Does that make sense? So why do we graph? To represent the infinite amount of answers that exist to an equation. It's just a review from semester 1. Anyways, it's as I spent way too much time on this one graphing question. It's as easy as this. What's your b value on number 2? -1. What's your slope? Up 2 over 3. So let's all go to -1 on the y, put a dot right there, and from that dot, I'm going to go up 2 over 3. So from that dot, up 1, 2, and then over 1, 2, 3. Okay? So let's put the dot right there. And then connect your dots. Put a line, line through it with the arrows on it, and you're done. Now let's say you think or you feel that line is too short, you want to make it longer, go ahead and use the pattern of up 2, 1, 2, over 1, 2, 3, and put a dot right there. So you could extend it as far as you'd like. And that's how we graph. Like I said, we should all know how to graph using y equals mx plus b. It's from semester 1, but we need to practice because tomorrow's section on 6.1, you have to be a pro at graphing with y equals mx plus b. So I might as well jump and do number 3 here. Y equals negative x. So y equals negative x. What's the b value on that one? The b value is 0, right? So if we think about it, once again, y equals mx plus b. The m is always with x. So the m right here is actually what? Negative 1. Perfect. So negative 1 is the m value. Now, we do want the m value in form of a fraction, rise over run. So how do I make this into a fraction? Put it over 1. Okay, now the b value is the number that's added or subtracted at the very end. And there is none, so you could put a plus 0 if you want. That way you know the b value is 0. So it does cross the y-axis at 0, crosses right here. And from that point, because it's negative 1 over 1, I'm going to go down 1 over 1. So if I go down 1 over 1, it'd be right there. Okay, again, if it's positive, you're going to go up. If it's negative, you're going to go down. And you always run to the right. So keep going, down 1 over 1, put a dot there, down 1 over 1, put a dot there. That way you could make your line as long as you want. And you could use that same pattern backwards to extend it the other way. So a lot of people get confused on this one. Just because there's no b value, they think, well, I don't know what to do. Yeah, the b value is 0, right? And that's it. Let's try a different one. A lot of people freak out with number 4, okay? I want to give an explanation number 4. There's different ways of graphing an equation that has a letter equal to a number. You could look at this in terms of y equals mx plus b, okay? Remember, the m value is always with the x. Is there an x right here? No. So what does that mean? That the m is 0, right? There is no x's, which means that there's 0 x's. And so if you wanted to, you could rewrite it like this. Y equals, there are no x's, 0 x's minus 4. Then you could clearly see, oh, the m is 0 and the b is negative 4, okay? You don't have to look at it in y equals mx plus b. You could look at it with the xy table, right? You could go to an xy table, and the only thing that this equation cares about is what? That y equals what? Negative 4. So here are your y values. That's saying that your y values are negative 4. And what about your x's? Is there even an x on this equation? No. So x, it could be anything you want because there's no x's. You don't have to plug it in. So x could be 0. It could be negative 2. It could be positive 3. Whatever you want for x's, right? Now, what kind of line do these coordinates produce? Let's go to 0, negative 4. 0 on the x, negative 1, 2, 3, 4 on the y. There it is. Let's go to negative 2, negative 4. There it is. Let's go to positive 3 on the x, negative 4 on the y. There it is. And we get a very clear line that's totally flat. So this is the way to explain why we end up with a horizontal line from left to right. Now, if you did look at it in terms of y equals mx plus b, yeah, it crosses at negative 4, and the slope is 0. Slope 0 means it's totally flat like the floor. It's not steep at all. So you could look at it with y equals mx plus b, or you could remember, oh, y equals negative 4. That means my y values are negative 4. X could be whatever I want. I end up with that same line anyway. Or the shortest cut that we learned last semester was if you have a letter equaling a number, you go to that axis, you go to that number, and you draw a line through it. So y equals negative 4, go to the y-axis, go to negative 4, and draw a line right through it. Now, if I would have said, like, graph y equals 3, okay, go to the y-axis, go to 3, 1, 2, 3, and draw a line right through it. It's really easy to graph y equals any number. It's just the line going right through that y value. Make sense? Okay. Now, what if it were x equals a number? I think we have one on here. Yeah, number 6. Let's jump to number 6. Since we were comparing y equals a number, let's compare now to x equals a number. Now, if you try to think about this in terms of y equals mx plus b, you can't. Why not? Because there's not even a y. You can't get y by itself, right? So you can't think of it in terms of y equals mx plus b, okay? So you need to go back to either an xy table or the shortcut that we learned. The shortcut is, it crosses the x-axis at 2, and you draw a vertical line right through it. But the actual xy table explanation is that your x values have to be 2. So x has to be 2, 2, 2. Y values could be anything you want because there's not even a y value in the equation. So you could put 0, -1, +2, whatever you want. What kind of line will this produce? 2, 0, 2 on the x, 0 on the y, 2 on the x, -1 on the y, 2 on the x, 2 on the y. This line is vertical. So again, the shortcuts. When x equals a number, you're going to go to the x-axis, you're going to go to that number, you're going to draw a vertical line right through it. When y equals a number, you're going to go to the y-axis, you're going to go to that value of -4, and you're going to draw a horizontal line right through it. So x equals a number is a vertical line, y equals a number is a horizontal line. Easy, right? Now, the explanation of why it's vertical and why it's horizontal is when you look at the xy table. Think of all your x values being 2. Your y value could be anything you want. It produces a vertical line. And you could use that same rationale for number 4, the one that's horizontal. Okay, what if they tell you to graph number 7? Well, first of all, in the instructions, they tell you change it from standard form to slope-intercept form, and then you graph it. Okay, I apologize for the different levels of volume that you're going to have on this one. But if I wanted to graph this one, I need to change it to slope-intercept form. I need to get in y equals mx plus b. You have to ask yourself, where's the y at? Is it on the left side of the equal sign or the right side of the equal sign? It's on the left side. It's definitely not by itself. You need to get it by itself. You need y equals mx plus b. You don't want x plus something, y equals something. You want y equals mx plus b. So let's get y by itself. What do I get rid of first? Let's get rid of that x. So let's subtract x and subtract x. And you can't really take away 6, take away x. So you're just going to rewrite the whole thing. It's going to be a 3y on the left side equals, now instead of writing 6 minus x, I'm going to write negative x with a positive 6. So negative x with a positive 6. For my final step, I'm going to divide by 3. And let me ask you this. What number is in front of that negative x?
3.
There's an invisible -1 right there, right? Even though it's just a negative sign, it's really a -1. So when I rewrite my slope-intercept form equation, the 3's cancel. Y equals, my slope is actually -1 over 3. And of course, it has an x right next to it. And my b value happens to be plus 2, because 6 divided by 3 is 2. Now that I know my m value of -1/3, -1/3 that is, and my b value of 2, now I could go to my graph, put a dot at the y-intercept of 2, and I could, from that point, go down 1 over 1, 2, 3, and put a dot right here. And then down 1 and over 1, 2, 3, and put a dot right there. So let me do that. And of course, connect your dots, and you're done. So I'm going to stop I'll continue, I'm going to stop right here in this class, and I'll continue with the rest of them in another class, and there should be an explanation to every single question uploaded by this afternoon. Let's actually go back to number 5. That one is in slope-intercept form, so it's really easy to graph. All you have to do is identify your m value, which is always in front of x, which is -3/2. That's your m value, -3/2. And your b value is +2, so your b value is +2. Once you know your m and your b, go to your b value first on the y-axis. It tells you it crosses the y-axis at 2. Now from that point, you're going to rise and run according to your slope. Because it's negative, we're going to be going down. Because the m is negative, we're going to be going down. And it's a negative rise, so you're going to be going down 3 units. 1, 2, 3, and then over 1, 2, and let's put a dot right there. And you could continue to go down 3 over 2, or you could even use that pattern backwards, over 2, up 3, over 2, 1, 2, 3. So you could extend the line in the other direction. So that one is pretty easy because it's already in slope-intercept form. But if we go down to something like number 9, number 9 is not in slope-intercept form. Okay, so on number 9, you want to get y by itself. You're going to have to get rid of that positive 2x by subtracting 2x. Subtracting 2x, you're going to rewrite it. There's a negative 8y left over equals, you can't really do the 8 take away 2x, so you're just going to rewrite it. And always rewrite your x term first, and that is a negative 2x and a positive 8 right next to it. Now, from here, I still need to get y by itself, so I'm going to have to divide everything by negative 8. Why? Because it says negative 8 times y. The opposite of multiplying is dividing, so to get rid of that multiplication of negative 8, you're going to have to divide by negative 8. Divide by negative 8, divide by negative 8. So I'm going to rewrite my y equals mx plus b equation up here. I ran out of space. So I will have, the negative 8's cancel, I will have a y all by itself equals mx plus b. So when I look at the value in front of x, it's a negative 2 divided by a negative 8. First of all, a negative divided by a negative is a positive. And then 2 divided by 8, you can't really do it. The fraction 2/8 could only be reduced by 2. So 2/8 reduces down to what? 1/4. Thank you very much. So we have y equals 1/4 x, and then 8 divided by negative 8, that is negative 1. And here is my slope-intercept form equation, y equals 1/4 x minus 1. And now you know that your slope is up 1 over 4, but you start with your b value of negative 1. So again, let's start with our b value of negative 1. Put a dot at negative 1 on the y-axis. Now from that point, we're going to be going up 1 over 4 because it's positive 1/4. So you go up 1 over 1, 2, 3, 4, and put a dot right there. And draw your line. The b value is negative 1. That's why it crosses the y-axis at negative 1, not at positive 1. But the slope is 1/4. You go up 1 over 4. Now you could continue to go up 1 over 4 if you wanted to extend the line further, or you could even go backwards with that pattern of down 1 over 4 this way to make your line further this way if you wanted to. But that's about it, guys. Once you switch it to slope-intercept form, it's really easy to do. You just go to your b value, put your dot there, and then rise and run accordingly to your slope. So if we look at number 8, number 8's definitely not in slope-intercept form. So it's in standard form. We want to get y by itself. And y is on the left side of the equal sign, but I need this y by itself. I don't need all this other junk. I need to get rid of all this other junk. I want y equals not 5y or minus 3x in front of that. I want to get rid of everything except y. So I want to get rid of this negative 3x. How do I get rid of something? By doing the opposite. What's the opposite of negative 3x? Plus 3x, that's right. And what you do to one side, you do to the other side, plus 3x. Now, some people might make the mistake and think, oh, 15 plus 3x is 18x. Wrong. You can't add numbers with letters. So you're just going to have to rewrite it, okay? So what do we have left on the left side of the equal sign? We have a positive 5y. We have the equal sign that comes down. And on the right side, we really do have 15 plus 3x. But instead of writing 15 plus 3x, I'm going to write 3x plus 15. You want the x term first and the number all by itself at the end. So my final step would be to divide by 5. Now, why am I saying divide by 5? Again, the goal is to get y by itself. And it doesn't say y plus 5. It says y times 5 or 5 times y. So if I want to get rid of the multiplication of 5, I need to do the opposite of multiplying by 5, which is dividing by 5. And you're able to divide everything by 5. So we do so. Now those 5's cancel out. I'm running out of space here, so let me rewrite my equation up here. So I will have y by itself equaling 3 over 5. That's going to be your slope, rise over run. And of course, there's an x right next to it. And then 15 divided by 5 is 3, plus 3. So now that it's in slope-intercept form, now I could see my slope, which is 3/5. My m value is 3/5. And my b value is 3. So once I know those two things from my slope-intercept form equation, it's really easy to graph. It crosses the y-axis at the b value of 3. So 1, 2, 3 right here. Let's all put a dot at the y value of 3. And then from that point, I'm going to rise and run according to my slope. Now, because it's positive, I really will be going 3 up. If it were negative, I'd be going 3 down. So from here, go 3 up, 1, 2, 3, and go 5 across. 1, 2, 3, 4, 5. So we're always going to be running to the right. And of course, you could use that same pattern of up 1, 2, 3, over 1, 2, 3, 4, 5, but backwards. You could go over 5 this way, down 3, over 1, 2, 3, 4, 5, and then down 1, 2, 3 right there to extend it in the other direction. Draw your line, and we are done. Whoops, kind of crooked. Put some arrows on it.